Namaskar, hello, and a very warm welcome to this live phone-in interactive program. I am Tanvi Khurana, and Department of Education in Science and Mathematics (NCERT) brings you this webinar series, Listening to Learn, यानी सुने और सीखे. Today we have come towards the session. This is session number 117th, and so far 116 sessions that we have done earlier. I'm sure you have enjoyed all of that. And in case if you have not seen those programs, you have missed watching those programs, you can always see them on our YouTube channel, that is NCERT official, and also on this playlist that we have. All you have to do is go to ncert.gov.in/webinar_series.php. Now let me tell you that today we are going to take up a very special topic, and that is analyzing human interaction with electronic displays in microgravity, यानी कि सूक्ष्म गुरुत्व में इलेक्ट्रॉनिक प्रदर्शन के साथ मानव सहभागिता का विश्लेषण. And we are going to talk about this topic in detail. We have an expert with us, and he'll be more than happy to answer all your doubts, all your questions. आप सभी अपने सवाल हम तक पहुंचा सकते हैं. कुछ भी कहना चाहते हैं, अपना कोई ओपिनियन शेयर करना चाहते हैं, तो आप वो भी कर सकते हैं. आपको हमें फ़ोन करना है. नंबर है 8800440559. अगर आप हमें इस वक्त देख रहे हैं हमारे YouTube चैनल पर NCERT ऑफिशियल, तो आप उसके लाइव चैट बॉक्स में भी अपने सवाल लिखकर हम तक पहुंचा सकते हैं. 11 बजे तक हम यहाँ मौजूद रहेंगे, और अगर आप अपने सवाल लेते हैं तो हम आपको पार्टिसिपेशन सर्टिफिकेट भी पहुँचाएंगे. इसी के साथ बताना चाहेंगे, आप PME विद्या चैनल नंबर 9, 10, 11, 12 पर भी इस वक्त हमें देख रहे हैं. और आप कहीं पर भी हैं दुनिया में, आप हमें अपने ओपिनियंस भेज सकते हैं, अपने सजेशन भेज सकते हैं. कोई ऐसा टॉपिक है जो आप चाहते हैं हम फ्यूचर में इस सीरीज़ में लें, तो आप वो भी हमें सजेस्ट कर सकते हैं. आपको सिर्फ एक इंटरनेट कनेक्शन चाहिए और हमारा प्रोग्राम देखना है आपको. सो डू वॉच इट टिल द एंड, एंड वी हैव एन एक्सपर्ट विद अस. बट फॉर द introduction of that expert, let me please introduce you another expert that we have with us in our studio, and he needs no introduction. He is the coordinator of this entire series, and he gets the credit of the success of this entire series, and he is nobody else but Dr. Gagan Gupta. Sir, a very warm welcome to you.
नमस्ते तन्वी जी, बहुत बहुत धन्यवाद. साथियों नमस्ते. आज हम अपने इस प्रोग्राम के 117वें सत्र में हैं. इस प्रोग्राम को हमने आज से लगभग 4 साल पहले, 4 साल से ज़्यादा हो चुके हैं, CSIR इंडिया और नेशनल ह्यूमन राइट कमीशन इंडिया के कोलैबोरेशन में शुरू किया था. आप लोगों का लगातार सहयोग मिलता रहा, आप लोगों के दिए गए सुझाव हमें मिलते रहे, और उन सुझावों के आधार पर हमने इस कार्यक्रम को आगे बढ़ाया है. आगे भी बढ़ाते रहेंगे. आप अपने सुझाव, जैसा मेरे साथी तन्वी ने बताया, आप हमें सुझाव भेजते रहें. आप हमारे सारे पुराने सेशंस, जैसा मेरी साथी तन्वी ने बताया, उसके अलावा आप हमारी वेबसाइट ncert.nic.in के इवेंट सेक्शन में जाएं. वहाँ पर आपको वेबिनार सीरीज़ लिसनिंग टू लर्न में आपको सारे सेशंस देखने को मिल जाएंगे. आज का प्रोग्राम हमारे लिए बड़ा इम्पॉर्टेंट है, बड़ा ख़ास है. इस तरह के प्रोग्राम, इस तरह के विषय को लेने के लिए हमारे पास बहुत दिनों से सुझाव मिल रहे थे. मैं सबसे पहले धन्यवाद ज्ञापित करना चाहूँगा अपने साथी प्रोफेसर यदाति नरहरि फ्रॉम इंडियन इंस्टीट्यूट ऑफ साइंस, जिन्होंने कि आज के गेस्ट डॉक्टर प्रदीप विश्वास को हमारे साथ इंट्रोड्यूस कराया, हमें कनेक्ट कराया. थैंक यू प्रोफेसर नरहरि फॉर योर हेल्प, एंड वेलकम Dr. Pradipta Biswas to our program. We are indeed privileged in having a continuous collaboration from the Indian Institute of Science, Bengaluru, and we believe that in future too we will keep on having active collaboration from Indian Institute of Science, Bengaluru. साथियों, आगे आने वाले प्रोग्रामों में, आगे आने वाले दिनों में हम कुछ खास विषय फिर से लेकर के आने वाले हैं, और जिसमें कि हम आपको ओर्स एंड मिनरल्स की दुनिया में ले जाएंगे, समुद्र में कुछ पार और ले जाएंगे, और इस हवा में स्पेस से जुड़े हुए विषयों पर ले जाने चाहेंगे. आज का जो विषय है वो स्पेस से जुड़ा हुआ विषय है. मेरे साथी तन्वी ने बताया, एनालाइजिंग ह्यूमन इंटरेक्शन विद इलेक्ट्रॉनिक डिस्प्लेज इन माइक्रोग्रेविटी. ये इस इंटरनेशनल स्पेस स्टेशन से जुड़ा हुआ विषय है कि वहाँ जो लोग स्पेस स्टेशंस में जाते हैं, वो लोग ग्राउंड पर किस तरह से कम्युनिकेशन करते हैं, ह्यूमन के साथ किस तरह से बात करते हैं, इस इंटरेक्शन की किस तरह से करते हैं। और इस पर चर्चा करने के लिए मेरे पास एक बहुत अच्छे एक्सपर्ट, जैसा कि मैंने अभी से आपको मिलाया, डॉक्टर प्रदीप विश्वास, जो कि डिज़ाइन एंड मैन्युफैक्चरिंग डिपार्टमेंट इंडियन इंस्टीट्यूट ऑफ साइंस में हैं। उन्होंने साथियों ही जॉइंड इंडियन इंस्टीट्यूट ऑफ साइंस in year 2016 after completing his PhD doctoral program in computer science from Trinity College, University of Cambridge, United Kingdom. He completed his doctoral program in 2010, and after that for 6 years he was associated with Cambridge University Engineering Department as senior research associate, as well as the governing body fellow at Wolfson College in a research project funded by the Jaguar Land Rover Technicolor BAE systems. He has so far handled 12 research projects funded very prestigiously by Indian Space Research Organization, Bharat Electronics Limited, Siemens, Defence Research Development Organization, Hindustan Aeronautics Limited, Department of Science and Technology, Ministry of Science and Technology, Government of India, Tata Consultancy Services, British Telecom, Microsoft, and many others. Dr. Biswas has authored or has been a lead editor in 6 books. You will see those books in the next slide. He has so far supervised 11 PhD theses and master theses, and his disciples are working in many prestigious institutions at very good positions. Dr. Biswas is an awardee winner of Grand Finale of Hackathon 2022, Best Paper Award of 47th Meeting World Wireless Research Forum, Facebook Responsible AR VR Grant Award, Microsoft Artificial Intelligence for Accessibility Grant Award, Department of Science and Technology Duo Fellowship with Universitat Autònoma de Barcelona, Spain, DST prestigious program SERB, which is now ANRF, Early Career Fellowship, Gates Cambridge Scholarship 2006 from Gates Cambridge Trust. He has got scholarship from Eddington and Rouse Ball Research Fund, Trinity College, Cambridge. His association with International Telecommunication Union (ITU) has been remarkable. He has been the vice chairman of its study group 9. He has been the co-chairman of Intersector Reporter Group of Audiovisual Media Accessibility Programs. He has been the vice chairman of Focus Group in Smart Grid. He has been the member of United Kingdom Research and Innovation International Development Peer Review Programs and convener of course, the convener of Bureau of Indian Standards, India, ISO panel on metaverse. So once again I welcome Dr. Pradipta Biswas. Dr. Biswas has been a superb academic fellow at Indian Institute of Science, and at the same time he has many other diversified interests in music, sports, etc., etc. Probably today we will not be able to see those sides of Dr. Pradipta Biswas, but it's all yours, Dr. Biswas, now. Thank you, please.
Thank you. Good morning. Welcome. Thanks for the very kind introduction, Professor Gupta, and also thanks to Professor Narahari for putting me in touch. So during the next 40 minutes, I will take you through space, literally, and I will discuss about this project. So you may remember that during summer this year, our second astronaut after Wing Commander Rakesh Sharma, Group Captain Subhangshu Shukla, he traveled to space. I was part of this astronaut training program, and in that relation I knew him almost like a friend from 2022 onwards, and to be honest, was a bit worried about also when the mission was getting delayed earlier days, but finally everything went fantastically well, also thanks to our colleagues at ISRO, NASA, etc. And this particular study I would like to discuss you through is known as the Voyager display study. So if anyone inquisitive enough to search Google and find more details about the study, so you can Google the term Voyager display and you will find the published details of the study. So let us move on. The first question is, we are very happy on Earth. We are living our life here. Most of us spending our entire life on Earth. Very few of us actually left Earth and experienced space. But then why we are talking about space exploration? So here you can see some example what probably all of you are aware of, like global positioning system, satellite communication applications, satellite meteorology, that communication wherever you are going with your mobile phone, you are using Google Map, or disaster help, knowing about that our weather forecasting, very many agrarian application that about agriculture. All these are possible due to our these satellites navigation. And besides that, of course, these marine litter monitoring, climate monitoring, all these are possible for space exploration or our quest for the unknowns. And also many technologies which we explored for space, like in recent time, astrobiology became a very active field, which also have applications for terrestrial medical applications. And what I am going to tell you about this human interaction with electronic displays, it also has similar application for our terrestrial aviation domain or drone interaction, and so on, as you will see in upcoming slides. So when we are, perhaps we are a bit convinced about that why we explore space, what are the various applications for space. So when something is in space, feeling is like that everything is automated or ground controlled, and everything is pre-planned, that from the countdown of the rocket, from the rocket firing and putting a satellite on space or sending a crew module, that things are pre-planned and everything is automated. But still, why we are talking about humans and why we are talking about investigating human interaction? So here are some interesting examples. So if any of you are interested in software engineering courses, or many of you are already learning programming and you remember this basic data type, int, float, etc. So this is a very interesting example, which is also taught in almost everywhere in the world about in the software engineering course, that this Ariane 5 rocket launch was a failure. Luckily, it was not fatal, so no one lost life, but there was a huge financial loss, almost estimated at 370 million. And it turns out that the cause was very simple, about some basic number formatting, and it was attributed to as a simple human mistake, which should have not have been happened for such a big program. And some more example of human issues is like that. Here I put two pictures. Mainly I sourced these informations from publicly available information. So this NOAA 19 Earth observation satellite, it's a very costly and very important satellite, and it just toppled while shifting on ground because all of the screws attaching it to the base plate was not attached for some reason, some human oversight. And then there is also this accident with NASA's Genesis spacecraft also. It was also not fatal, but a lot of important samples were lost just because someone by mistake attached the parachute in a wrong way. And then if you look at terrestrial aviation example, there are many accidents, even many fatal accidents are attributed for minor human error, either during operation or during design space. And taking it together, that analyzing human factors become an important issue even for space applications, whether it is for on-ground operation or whether it is for operations in microgravity or planetary or lunar surface operation. So understanding human range of abilities of a human in different circumstances, this is something very important topics, even though majority of operations are automated or pre-planned. So in that context, we will just look a little bit in history before jumping back to present and speculating about future. So we will talk about a specific type of movement called rapid aiming movement. But before that, let me give you a small example, or you can also take it as an exercise after when you are taking your next break, that just try to type a message when you are walking with your smartphone. And in top left, you will also see I'm trying to use a touchscreen computer while inside a car. And you will see that it is not as simple as you are doing when you are sitting on your desk. So as I mentioned, this type of movement of tapping, catching, holding, these are termed as rapid aiming movements. And their characteristics are they are very quick. Like when if any of you are like cricket enthusiasts like me, that you may remember when you are hitting a ball or catching a ball, you do not have too much time to think. That you have to do almost like act instinctively. So in more appropriate term is that it is quick, accurate, and pre-programmed. And you may think that, or also you may note that still the typists many times they type without looking at the keyboard itself. It's something like a muscle memory. So and this is also very innate that even a newborn child, even before its vision is completely developed, they also undertake these rapid aiming movements. And this type of movement started to be analyzed long ago in the last decade of 18th century. One researcher, Woodworth, he was pretty fascinated by the accuracy of the construction workers, that how accurately they operate these sledgehammers. And he undertook some very interesting studies using the material available in the 18th century and proposed that there are two phases of movement in this type of rapid aiming movement. One is vision controlled, and another is based on muscle memory, or which is not directly controlled by our vision. So that happened in the last decade of 18th century. And then we will jump to 1954 or mid 19th century. This gentleman, Paul M. Fitts, he came up with this law where T stands for the time to complete a rapid aiming movement. And this was the time in 1950s where many researchers were influenced by this Shannon's information theory. So when you will grow up, you may read about that. That was one of the big breakthrough that time in both semiconductor, information communication technology. We often talk about ICT technology, that quantifying the amount of information. So coming back to our topic, this gentleman Paul Fitts, he proposed this law based on 4 experiments. One of them was this reciprocal pointing experiment, that where one person was moving the stylus between two metal slits. And in 1950s, electronics was in a nascent form. So he used metal strip and some also buffer area to catch movements where the stylus could not be stopped within this thin strip. And based on his analysis, he came up with this law that E is the time. A and B are two constants which has to be empirically measured. Log 2 is the log formula. I hope you have already started reading about log formula in class. 1 plus d by w, where d is the distance between this metal strip and w is the width of this strip here. So it was published in 1954 in Journal of Experimental Psychology, and there are many other papers, and it stayed like that. There were many psychologists, they tried to analyze this law, they wrote research papers on why this law works, what are the underlying theories from throughout from 60s to 80s, but it mainly stayed as an academic exercise. But then something interesting happened on the last year of the 1970s, the decade of 70s, or 1979 to be precise. This young engineer, that time Stuart Card, who later became one legendary figure in the field of human-computer interaction. Even he authored the very seminal book on the psychology of human-computer interaction. But earlier days, he used this that time little-known Fitts law to predict to Xerox PARC that mouse is going to be the fastest pointing device compared to joystick or a head movement detector. And based on his analysis, Xerox PARC started manufacturing mice, followed by Apple and other companies. And still now, when you are using a desktop computer, you are still using some form of mouse, except when we are using touchpad device. And that's make Fitts law very important. And still now there is a whole bunch of people who are expert in Fitts law. And the original experiment of Fitts, it was slightly modified and became part of this International Standardization Organization, or ISO 9241 standard, for evaluating any pointing device for electronic screen. So from 1979, we'll take another jump that people already studied Fitts law in various situations when people are manipulating objects under a microscope, underwater, etc. What about in microgravity situation? Because when you can look at many YouTube videos, I will show you some during my talk, at the ISS that or International Space Station, that people operate computers, laptop, iPad, everything. So does this Fitts law also work in microgravity? So there were various effects. Now, it was notoriously difficult to simulate a sustained microgravity environment on Earth where a human and a machine, they can both samples.
Yes.
Sir, sir, am I audible to you, Dr. Biswas?
Yes.
Okay, there is some
Yes.
communication gap. Just a second, friends. So today's talk is is over about how the communication is going to take place between the systems. Dr. Biswas is narrating right from the beginning that how the things take place with the human errors and how do we manage with all those things. So now, yes, correction is all right now. Dr. Biswas, please continue.
Thank you.
Sorry.
So there was one study in 2012 in something called a parabolic flight. So parabolic flight is like you really need some sort of training to be inside. So there is an aircraft, you can see my hand, and it kind of dives and then it's again fly up. So when it is diving, you can get a microgravity for around 22 seconds. So some of my colleagues, they last year also experienced the parabolic flight. But still, it only gives you microgravity for about a few seconds. So there comes the International Space Station, which will give you sustained microgravity. And there is this Christina Holden. She undertook a very seminal and thorough study involving 7 astronauts in 2023. She published results on that how we operate with electronic display in microgravity. And the study went for more than 3 months, but still that study did not talk much about Fitts law, but mainly it talks about that whether there is a difference between human machine interaction on ground with and at the space station at different phases of flight. So in the context that why we only interested on doing that why we should analyze this human-machine interaction in microgravity in so much details. So here I will show you 2 videos. So this gentleman, he is the group captain Ajit Krishnan. So he is one of the 4 astronaut designates of India. So he also undertook his MTech degree with me in IISc. And we developed this virtual reality simulator for simulate something called a deorbiting maneuver. Say, for example, you are in a crewed mission, and there are some reason that you have to quickly get back home. So what you do that you align the spacecraft with the respect to the rotation of Earth, and then you fire the thrusters so that the spacecraft deorbit and come out of the orbit, and then gravity will take care. And we did some very detailed studies. So here I am donning some EEG tracker. Also, this VR headset has inbuilt eye tracker. It's showing where I am looking at. We investigated different types of controls for controlling a spacecraft. And then we also worked on analyzing emergency response, that if something on board emergency happen, what will be the sequence of action? And the sequence of action often involved operating a crew console for pressing a few buttons to respond to the emergency. Now we make a virtual reality immersive model for all these operations, but everything happens in our lab. And we do all analysis in a on Earth, where we have 1G plus 1G. So how it will affect, or how we can calibrate this model in microgravity, because all these operations will happen when someone is outside Earth on space in microgravity. So in that context, we designed this study to analyze this pointing task. I will show you the example of the task in a second. And also I undertook some cognitive and mental well-being tasks just to make sure that I did not know whether I will find a difference or not between ground and microgravity, because that is the whole point of doing the experiment. But if I find a difference, that whether this difference is happening due to microgravity or it is due to some cognitive or mental well-being effect of the astronaut there. So here you can see one such task, that where she is, this is recorded in my lab only. So the task requires to point this white dot in a set of blue dots. And here she is undertaking it with her finger. And then we can also, or we also undertook the same task with a stylus, or to be precise, a Apple Pencil on an iPad. And also we undertook this something called N-back task. So many of you in childhood we play a memory game, that where you have to progressively remember more and more bits of information. So the N-back test is very similar to that, that you have to remember certain bit of information. And we will check that whether your information retention ability has been affected by microgravity or not. So, and also we undertook some self-reported scales. So these scales are not designed by me. So these are established scales by World Health Organization, or already exercised by many researchers worldwide. So we take two such scales which can quickly be answered, and astronauts, they are super busy when they are somewhere. So it's not like that they are going there and taking rest. They have a very packed schedule. So we make sure that total study duration does not cross more than 20 to 25 seconds. So here you can listen a small clip from our astronaut himself, who will quickly explain the study.
Namaskar. Electronic screens are widely used in space vehicles that carry humans to space and space stations where crew live and work in space. Glass cockpits and touchscreen enabled multifunction displays are already being employed in aviation platforms like aircraft and helicopters since long. Astronauts may have to use controls on the electronic screens for various purposes, which may include some of the mission critical functions, especially in case of unexpected situations. The researchers from Indian Institute of Science in Bengaluru, India, aim to investigate how microgravity conditions of the space station affects the interaction of the astronauts with the electronic displays, and how the long-term use of such electronic displays affects the cognitive and mental well-being of the astronauts. As a part of this experiment, I will be taking multiple tests through web-based applications that will involve pointing tasks, wherein I will be repeatedly tapping on a white box on a tablet using fingers and a stylus. I will also take an online cognitive test that involves remembering the position of a red square in a grid and filling out 2 other online questionnaires on general mental well-being. This study is aiming to investigate the effect of microgravity on human interaction with electronic screens, followed by an analysis of pointing tasks under microgravity and the effect of the International Space Station environment on mental well-being. The results from this study may help designers of cockpits and crew consoles of future space vehicles and human habitats to design better crew-friendly displays so that the astronauts do not have to struggle, especially in those critical situations wherein off-nominal scenarios are taking place. Thank you. Dhanyavad. Jai Hind.
So next, I will quickly take you through a few results that I obtained, and I should tell you a disclaimer at this point that in science, what we always do is we follow a procedure called peer reviewing. So, for example, जब आप कोई exercise करते हो, you after करने के बाद you give it to your teachers, and the teachers they correct it. So here we are professors. So, but saying so, whatever we do, we submit it to other professors, other senior researchers to check. Just जैसा आपका टीचर आपका स्क्रिप्ट में चेक करते हैं एंड बोलता है जो ये आपने गलत लिखा, इसमें रेड सर्कल है, इसको ठीक से लिखो, हम लोगों को भी वही करना होता है. बट बिकॉज दैट्स हाउ साइंस स्टैंड्स देयर एंड दिस प्रोसेस कॉल्ड peer reviewing. So whatever I am suggesting that it has to be peer reviewed. तो क्यों मैं अभी ये बोल रहा हूँ, जो ये जो results आपको दिखा रहा हूँ, so I already we found this result, so I have good confidence on what I am going to present to you. But also it's a disclaimer that this results is under peer review now because the results are obtained very soon, and a good peer review process almost take a year. So we have good hope that we will publish these results very soon in a good journal. But again, you do not bother about too much about the details of the research, but whatever is the big picture that you can take home. So with all this disclaimer, let me take me through you that what we mainly found. So what we found that this we started this discussion with this Fitts law, this 1954 law, and 1979 someone used it, and then we undertook it in microgravity environment. First point with what I would like to emphasize that yes, this Fitts law, it works in microgravity. So I put some values you can see is more than 0.97, 0.88, 0.93. It shows that the movement time and a particular parameter called index of difficulty, again you may not need to go into detail of that parameter right now, that they strongly correlate, and that's why you can see there is a straight lines here. But more importantly, what we get that there was no significant difference between the ground students who undertook the study on ground and crew who undertook the study in microgravity. However, we found a significant difference between stylus and finger tapping. So remember, they did the same pointing task with tapping with finger and also with a stylus. And we found that they would do it faster with the finger tapping than stylus. Why so? I do not know, but we found it for different groups of users. And then what we try to do is also we try to do a more detailed analysis that yes, it is true that overall timing was fine. So in this picture, what you can see is like that there is a source and there is this destination. Source is black, destination is pink. And for example, see, I am very accurately tracking my finger movement and I am trying to say tap on the screen. So ideally, I should move my finger or stylus in a straight line because a straight line is the minimal distance in a Euclidean coordinate system. But in reality, for various factors, this is the actual movement path, which is a bit convoluted lines. So then researchers, in particular one very famous professor, Professor Scott McKenzie, he defined a set of parameters. Again, we need not to go into detail of all these individual parameters, which measures that how good was the pointing or how well I am following a straight line. And of course, as I told in the first example, let's say when I am now typing something on my keyboard or I am tapping on the screen, it will be almost like a straight line. But if I do the same thing when I am walking, it will not be a straight line because I am walking and my whole body is moving like that. So what we did, that we did not have any finger movement tracker or anything. We could not carry anything there. The iPad and Apple Pens all were already inside the International Space Station. So, but we make the software in such a way that when the finger or stylus is very near to the screen like this, it starts tracking the movement. And what we find that overall, although there is not a difference in the pointing and selection time in millisecond between people who are on ground and who are on space, but it shows that there is a difference that how people adjust the homing movement or stopping this finger movement during tapping in microgravity compared to people on ground, and which also lead to future research that where we need more accurate device to further understand something we term as fine motor movement, because it has very interesting applications in future. So in summary, what we mainly find that the pointing and selection time was more or same, or there is no statistically significant difference, although there may be some fine difference in the when people are stopping the movement. And we also analyze the results from the cognitive test, the NBAC test. We do find there was some different strategy in undertaking the task, like while the ground crew who are also pilots, they tried to be more accurate, but the groups of students and the astronauts, they tried to do it faster. So they did have some errors, but that was insignificant. And again, bigger story is that we did not find any significant effect of microgravity on their memory retention ability. And similar thing about the mental well-being or perceived stress, that according to even medical analysis, that astronauts they did was not under any stress, and they reported themselves as mentally well. So whatever differences we are finding, even if it is minor, that is entirely due to microgravity, not due to any other mental or any cognitive reason. And then this is a proud picture, like 21st August, we got felicitated by the very honorable our ISRO chairman in presence of the astronauts. But then let us move forward during the last 10 minutes maybe, that how we are going to utilize these results. So how you are trying to make use of it. So here I have divided all human machine interaction into 4 quarters based on the co-location, or that where the human and where the machine is. And you may think about 4 combinations, like where human and machine can both be on Earth, which is our standard situation. Human can be on Earth and machine in space, that there is the ground controller in Houston or Japan or in Canada who are controlling things there in space. This is the most common mode of operation. Then the human and machine can be both in space. So in a second, I will show you the Canadarm, where the system can be operated from space, from the International Space Station. And then there is also this combination that human in space, machine on Earth. But presently we will not go into this, because there is not any significant application I could think of that where the human is operating a machine on Earth from space. Maybe we can think that someone is controlling a planetary rover from an orbital module. But we will not go into details of this. So we will stay on the right-hand quarter. And exactly in the similar logic, the IEEE, the International the IEEE organization, they divided space robotics into 2 main categories: microgravity robotics and planetary rover system. So in the microgravity robotics, in most cases, both the human and the device or the robotic manipulator, they are both in space. While in planetary rover system, the machine is in a planetary surface or lunar surface. You may remember that this 23rd August, now defined as the National Space Day, the day where we make a soft landing on the moon, and the Vikram rover started strolling on the lunar surface. So the lander will be maybe on lunar or Martian surface, but the controllers will be from ground. And also the robotic arms attached to the International Space Station, they are mostly controlled also from ground. So this is one example. Again, this is a YouTube video where you can see how people control this Canadarm, which is a large manipulator. attached to the International Space Station. And I am just briefly showing you the controller they use and how they control it, that there are two joystick-like devices and there is an entire array of screens. You can see these small screens, and these are mounted in the International Space Station, and they can also directly see the arm outside the space station. And it's not very easy. People need to be trained to operate that. To the whole big Canadarm, it has this is the picture of the Canadarm mounted to the International Space Station. So it has cameras mounted throughout its surface, and people have to look at this camera view, and accordingly they have to control the Canadarm, which has many functions: docketing, picking and placing objects, holding another dexter manipulator, which has a more dexterous manipulation device, and so on. And then this is about in the International Space Station. But then we also move further, and we reached lunar and Martian surface. So this was the very early generation rover, and you can look at the size, and this is the latest rover. You can look at the size difference, and here also you can see a list of rovers, and these are all publicly available, so you can just Google rovers, and you will get all details from Wikipedia or any other sources from NASA and ESA. And then we went further to develop even this Ingenuity helicopter, that which can stroll a large area on the Martian surface. Here you can see the flying of the Ingenuity helicopter, and it can give me more feedback from an aerial point of view. So we are now in an era that where we are flying machines not only on Earth but on Martian surface. But how we can look at the human interaction with these devices? So here I will quickly take you through some of our research in lab, and of course we'll be glad that in future if you would like to be involved, and I am sure many of you will come to IISc or IITs and in other institutes, maybe ISRO, ISER, and contribute to similar research. So here is one platform we developed in lab, that where we developed this rover, and this is voice controlled, and this tree in the middle of lab, this is a hologram. So we make a situation that where a rover will carry a drone, small drone, like you can think that rover is carrying a helicopter, and the same person, he can control the rover with voice and fly the drone with a hand controller. So these are all kind of like futuristic plans. But anyway, we can be futuristic. And then we also do some testing on what we term as off-road testing, that how the rover can move in difficult surfaces. Of course, we could not send it to Moon or Mars, but we can test it in some slope and very rough surface to see that how it works. And when we are convinced with the design, we explored something more interesting, that why you should look at a multiple screen and look here, 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 and control it there. Why don't you immerse yourself on the ground and then you control something more easily? That means I am seeing here, I am seeing a room here. Why not I can see the whole, say, Martian surface or lunar surface here, and I operate the device as if I am sitting right there. So in that context, you can see that we developed some technology. Again, we need not to go into very much details of that where in this video here you can see this is a live camera feed, and then we used a technology called 3D reconstruction, that from a video we make a whole immersive environment of wherever this rover is being operated on. And as the rover is moving in real life, you can see or track its movement. And this is not like you are looking at a single screen and seeing that, hey, this is moving here. You can immerse yourself in this environment, and the whole immersive environment you can create just from video. And how this rover is moving, that also we did something interesting. So you may heard about all this term ChatGPT, Llama, etc. So these are called large language models. So we integrated that with a rover. And now what you can do that you can just give natural language instruction or even show an image and the rover will go here. And here I will give you two examples. The later example is actually developed by one class 10 student herself. So this is not very far away. And the rovers you are seeing here, these are not very costly things. These are bought from Amazon. Only about 1,500 rupees it cost. So you can buy it yourself. And one is moving based on LiDAR, another is moving based on ultrasound. And you can show a picture. Of course, this need to be pre-decided, but the rover will follow or go anywhere based on your natural language instruction. You can just like a human, you can tell that go to base station, charge yourself, or go to the tool station, the rover will do so. And all these are with very low cost devices. And then what you can do that we can put the whole picture together. That means that we can make an immersive environment where you are sitting in a remote location and you are instructing a rover or a manipulator with natural language, and the rover is operating somewhere else, and you can track it in real time. So these are two camera views, and this is the rover is moving based on this natural language instruction that I just explained. And you can view this. So this is not the middle part of this. This is no camera view. So this is 3D reconstructed using a technology called Gaussian splatting. So you are sitting on your lab, in your school, in your office, and you can put a headset or you can see on a screen, and you can give a natural language instruction that go to tool station. The rover will move in real life in a remote location, and you can visualize it in real time from your remote location. So we term it as something like an interactive digital twin. So again, moving on, and these videos are all available in YouTube, so you can also check for yourself. So I will just move on. So finally, we also worked on some manipulators. So here you can see this is a manipulator we bought, and here we can tap on a screen and the manipulator goes wherever we are tapping at. And the interesting thing is that we tested this system from Toulouse, which is 8,000 kilometers away. So someone can tap on a screen from 8,000 kilometers away, and the rover, the manipulator, it moves to desired position based on his tapping instructions. And then we tried to make a manipulator which has a lot of degrees of freedom and more range of motion. So again, the same thing, you can also use it for drone, and as well as an equivalent of Canada, that like a space station manipulator. Of course, this is miniature version, but you can increase it or make it more robust based on the requirements. And then you can control it from another remote location. So here we make a very primitive user interface, and what we did that we put motion capture sensors on the arm, and you need not to transmit a video which requires a lot of bandwidth, etc. But you can control this manipulator from a remote location, and you can get real-time feedback based on the motion capture system or the markers that is plot on the arm. So overall, you can move a rover, that means a moving robot, as well as a manipulator, both from remote location, and you can also track it in real time in a immersive view. And as we are moving forward with this microgravity study, so presently we only undertook a study in microgravity where you are tapping on a screen, but now we are moving on that where you will control a complex mechanism from microgravity. And that's why it's very important to understand this fine motor movement, because a small movement by you can be translated to a large movement of a robotic manipulator or rover. And we are presently undertaking research along with our other European partners on this respect. So finally, to summarize that what I would like you to take away message among all these theories what we presented, that let's acknowledge human involvement in operation for space technology, not many things are automated, but still there is the human involved, and in many cases, emergency or of nominal situation, the human have to take over automation and undertakes tasks. Examples are this deorbiting maneuver, onboard emergency, human-robot interaction is one. I described you a study undertook again at the International Space Station, also explained the rationale of the study, why we designed the study, and what are the preliminary results we obtained. I showed you some interesting novel human-robot interaction using visual language model and 3D reconstruction technique, where you can immerse yourself inside the environment and directly control robotic agents. And finally, we believe that these results will be useful for future lunar or Martian missions, as well as in the context of Bharat Antariksh mission. Of course, our learned colleagues at ISRO, they will decide that how to use these results. But we believe that once we publish these results, that will be useful for not only by a lot of people who would like to undertake research in space technology, and maybe आप लोग भी होंगे जो who will join ISRO or who will join these educational institutes and contribute to the research on space technology. And space technology is something like, still now this is an area where the whole earth it's unified together instead of all political and other differences. And this is a quest which kind of like a singular quest of the whole humanities together to know the unknowns. So with that, I will stop my presentation. Again, many thanks to Professor Gupta and Tanvi ma'am for inviting me and allowing me to give this presentation to you. And if you have any question, I'll be very happy to take on. Thank you.
Great, Dr. Biswas. We would have loved to have you in our studios to have this discussion further on, but we will call you some other time to have discussion on this. We are getting some questions which are scientific in nature and some are in commercial in nature. So since time is running out, so I mean, friends, viewers, you might have noticed it today that how the present research, the frontline research is taking place in our institutes in India, which is taking over in the International Space Station. You might have listened the whole conversation which Subhanshu Shukla made in space at ISS. So before I go for further, may I request Tanvi to take the commercial kind of question today with Dr. Biswas first.
Absolutely, sure sir. Dr. Biswas, it was a wonderful conversation, and yes, we are privileged to have you in this discussion. Let me just raise the question that we have. Sir, the question is, do we have scope of startups in the area of space in general and in the area of communication with space stations, and are there any Indian companies working for it?
Absolutely. So presently, the government ISRO, you may heard about this InSpace, INSPAC, InSpace organization, who are mandated to involve private players and startups. I myself also working with a few IISc-based startups, and I think startups will play a very essential role on figuring future mission, both from manufacturing parts of the space station or crew module to undertaking experiment and bringing the good results for a bigger audience. So startups are already playing an essential role. Yes, unlike many financial startups, maybe the revenue will need to wait. But I think we are very near that. We already have the first privately designed rocket fired, and many startups already designed satellites. And I also personally know startups who are very closely working with the Human Space Flight Center, providing them sensors and developing analog missions with them. So yes, startups are playing a very essential roles, and now I think everyone is encouraging more involvement with startups and private players.
Dr. Biswas, I am fascinated having seen the videos which you have displayed here of visiting to your laboratory sometime soon. Very quick question, very quick query, very little time do we have, that what after ISS? It is going to be virtually deorbited in 2030 or so.
So I think it's very interesting that I talked to a few European colleagues recently, and many European colleagues also looking at us about the Bharat Antariksh mission, and they are looking forward to undertake their study here. So we are already launching foreign satellites. NICER will launch another big US satellite we will launch soon. And now people are also looking at us for our own space station, where not only us, but the rest of the world will also undertake experiments in us. So, of course, yeah, International Space Station does have a mortal life, but now it is our turn to make our own space station and undertook our own study and even offer the service to other friendly nations. So yes, I am also looking forward, like the whole country, to the launch of both Gaganayan mission as well as the Bharat Antariksh mission.
यस डॉक्टर विश्वास, आपके जो इंटरेक्शन आज हुआ है ना, उसने हमारे रोए खड़े कर दिए हैं, बिल्कुल एक्साइटेड कर दिया है, बिल्कुल कि यस वी आर नॉट बिहाइंड, rather we expect ourselves to be front runner and to be the world leader, of course. So thank you very much, Dr. Biswas, for being with us today. We are really privileged having you here with us today. Colleagues and friends, I must speak that all the videos which have been given today, they are belonging to Dr. Biswas. See, however, this NCERT presentation today, Listening to Learn series, is an open source, but all the videos are copyrighted material with Dr. Biswas. If you want to use, you can take the permission, you can seek the permission from Dr. Biswas. So once again, I thank you, Dr. Biswas, for being with us, and looking forward meeting to you very soon in your laboratory and in our studio as well. Thank you very much. Thank you.
Thank you.
Thank you, Dr. Biswas, again for being with us, and it was an honor, and your presentation was indeed energetic, and science students were so excited to hear you and to watch you. So thank you once again for your time. And thank you, Dr. Gagan Gupta, for being with us. Yes, so let us announce the next program that we have lined up, sir.
Friends, आप लोगों की बहुत दिनों से हमारे पास एक डिमांड थी, हम उसको पूरा नहीं कर पा रहे थे। हालांकि हमने जियोलॉजी के बहुत सारे सेशंस लिए, लेकिन उसमें पर्टिकुलर जो डिमांड थी वो थी ओर्स एंड मिनरल्स एंड देयर इकोनॉमिक इम्पोर्टेंस। सो ऑन 5th of December, next Friday, we are going to have Professor K.V. Krishnamurthy from Geological Society of India, and he is going to precisely speak on ores and minerals and their economic importance. So be with us, friends, on 5th of December, Friday at the same time, 10 o'clock. Goodbye. Namaskar.
Okay. Thank you so much, Dr. Gagan Gupta, for announcing our next program, and I'm sure all the viewers, they'll be looking forward to it. थैंक यू टू ऑल द व्यूअर्स एज वेल हमारे साथ जुड़ने के लिए। आशा करते हैं आपको ये कार्यक्रम बहुत पसंद आया होगा। अगर आपसे छूट गया है तो NCERT ऑफिशियल पर जाकर आप इसे दोबारा देख सकते हैं, जब मर्जी दे सकते हैं। और इसी के साथ हम आज का अपना एक ख़ास कार्यक्रम लिसनिंग टू लर्न की सीरीज़ यहीं ख़त्म करते हैं, पर पूरे दिन में हमारे पास हैं बहुत सारे कार्यक्रम आप सभी के लिए। एक छोटी सी झलक आप देख सकते हैं अपनी स्क्रीन पर। शेड्यूल है, अगला जो कार्यक्रम आप देखने वाले हैं वो है 12 बजे से 12:30 बजे तक कक्षा 6 के सभी छात्र हिंदी का एक कार्यक्रम है जिसका विषय है गोल। इसे देखना बिल्कुल मत भूलिएगा और आप इसी तरह हमारे साथ जुड़े रहिए, पूरे कार्यक्रम देखते रहिए। कोई भी सवाल हैं तो आप हम तक पहुंचाते भी रहिए। आशा करते हैं आपका दिन अच्छा जाए, एंड आई एम तानवी खुराना, एंड नाउ आई विल टेक अ लीव ऑफ यू। थैंक यू सो मच। नमस्कार।